So the 10.8 notes, vectors, page 4. And so this page is entirely examples. At the top, example 7 and 8 are completely algebraic. And then at the bottom, example 9, we're going to tie the algebra to the geometry of the vectors. So let us start. Example 7, vector v is negative 1, 4. We want to find 3v, 1/2 v, and negative 2v. Fortunately, this works pretty much the way you want it to. If I'm multiplying a scalar times a vector, I multiply that scalar by each component, my horizontal component. Here's my vertical component. And I get the vector negative 3, 12. And that's it. So same thing here for 1/2 v. 1/2 times our vector negative 1, 4. 1/2 times negative 1 is negative 1/2. 1/2 times 4 is 2. And then our last one, we have negative 2v. Negative 2 times negative 1, 4. Keep in mind, just like when we did the subtraction, the negative 2 makes this go the opposite direction. And I get a positive 2, negative 8. Example 8, we've got vector u is 3, negative 2. Vector v is negative 1, 4. We want a new vector w, which is going to be 3u plus 2v. And this is going to work, again, the way you think it's supposed to. I've got 3 times the vector, 3, negative 2, plus 2 times the vector, negative 1, 4. So now I'm adding the vectors 9, negative 6, and negative 2, 8. And I get w equals 9 plus negative 2 is 7. Negative 6 plus 8 is 2. And there's my vector w, 7, 2. Fairly intuitive with the vectors. Okay, so example 9. We want to see what happens as we modify some of these here. 2v is 2 times negative 2, 2, which gives us the vector negative 4, 2. I'm going to go ahead and graph v first. And I thought it would be helpful to have these not numbered, and now I'm regretting that decision a little bit. 1, 2, 2. Negative 2, positive 2. Here's my vector v. And we are going to keep going so that I can graph 2v. There's 3, there's 4. Pick a different color. And we go all the little lines. Yeah. And we see that 2v is just twice as long as v. Notice that it's still going in the same direction as v. Direction does not change, only the magnitude. We're doubling that magnitude. So we've got vector w, 3, 4, minus vector v, negative 2, 2. 3 minus negative 2 gives us a 5. 4 minus 2 gives us a 2. Six, I'm not going to worry about numbering, but I am going to mark them off. I think that when I rewrite these notes, I will go ahead and stick numbers in here. Okay, so w is 3, 4, 1, 2, 3. So here's vector w. So V was negative 2, 2. If I'm subtracting that, it's the same as adding the opposite. Sometimes it's a struggle. So it'd be the same as adding the vector positive 2, negative 2. So that's what I'm going to do. From the terminal point of vector W, I'm going to go positive 2, negative 2, so here is my vector negative V. And when I add those, W plus negative V, I get this vector, W minus V, 1, 2, 3, 4, 5, up 1, 2. So that's exactly what we just got. Okay, on to C. I've got V plus 2W. So again, my V is negative 2, 2. I don't try to do a lot in my head. I'm going to write everything down. W is 3, 4. When I combine those, I get negative 2 plus 6, which is 4. I get positive 2 plus 8, which is 10. So I am super gonna just fix these notes and put numbers in here as soon as we're done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, barely fits. So I've got V, which is negative 2, 2. I have got W. And W I'm going to add twice, but on the picture here, I'm just going to go ahead and create 2 W's just to see that it works the same way. So I've got 3, 4. So from this point right here, from our terminal point, I got 1, 2, 3, up 1, 2, 3, 4. So there's my first W. I'm going to do that again. 1, 2, 3, up 1, 2, 3, 4. So from here, here's my second W. Notice that just extended W to 2W. And so here is our resultant vector. According to the math, I should be at 410. 1, 2, 3, I don't know how to count, 4. Up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right there. Let me see if I can erase my little mistakes here. Apparently not without erasing everything else. 1, 2, 3, 4. So it's that counting by 2 that's an issue. And so this is the vector V plus 2W. Now for D, we're going to cheat just a little sometimes. Well, no, we're not. It's a little cumbersome to do this graphically as they get a little more involved. Negative 2, 2, minus 3, times 3, 4. I'm going to go ahead and write this out just so I don't have to think too hard. I got -2, sorry, -4 4 minus 3 times 3 is 9, 3 times 4 is 12. And so -4 minus 9, -13. 4 minus 12, -8. Okay, let's see what happens when we draw this out. I think I'm going to have to count by ones because I don't think I'm going to get that -13, -8 on there if I don't. So let us just go -2, 2. There's V. Just blow it up a lot. And then we're going to do that again. So there's my 2V. I've got -3W, or my W is that 3, 4. So just for reference, 1, 2, 3 up, 1, 2, 3, 4. This is what positive W looks like. That's not the direction we're going. We want the negative W. So instead of going forward 3, we're going to go back 1, 2, 3, down 1, 2, 3, 4. So there's a negative W. Do that again. 1, 2, 3, down 1, 2, 3, 4. There's my second negative W. And then last time from right here, back 1, 2, 3, down 1, 2, 3, 4. And so this big chunk right here is my -3W. See if we ended up where we were supposed to. So from, again, I'm a lefty, I'm going to draw this backwards. My initial point is the 0, 0. My terminal point is right here. We're back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Down 1, 2, 3, 4, 5, 6, 7, 8. So this vector right here, -13, -8, is also my 2V minus 3W. Okay, and so if you can crank these answers out algebraically, you're good. There are going to be a couple of times you're asked to do this geometrically. It's sometimes nice just to be able to compare across. Make sure you're really setting this up the way you think you are.